What is a transistor? A transistor is a three-terminal semiconductor device which operates by flow of charge carriers through its regions. It is used for amplification, switching, and signal modulation. Bipolar junction transistor. A bipolar junction transistor, BJT, is three-layer 2-junction NPN or PNP semiconductor device, sandwiching either a P-type or N-type semiconductor between a pair of opposite types. The term bipolar denotes that the current flow in the device is due to both electrons and holes. There are two types of BJT. PNP transistor, when one thin N region is sandwiched between two thick P regions, a PNP transistor is obtained. NPN transistor, when one thin P region is sandwiched between two thick N regions, a NPN transistor is obtained. What is an NPN transistor? An NPN transistor is made by placing a thin P-type semiconductor between two N-type semiconductor regions. It has three terminals: emitter, E, base, B, collector, C. The transistor forms two PN junctions: emitter base junction, collector base junction. Structure 1. Emitter supplies electrons to the transistor, heavily doped, always forward biased with respect to the base. Main function: provide a large number of charge carriers. 2. Base: very thin and lightly doped region located between emitter and collector. Controls the flow of current. A small base current controls a large collector current. 3. Collector: collects electrons coming from the emitter, moderately doped, has a larger area than the emitter, always reverse biased with respect to the base. Working of NPN transistor. Step 1. The emitter base junction is forward biased. This pushes electrons from the emitter into the base. Step 2. Since the base is very thin and lightly doped, only a few electrons combine with holes. These electrons form the base current, IB. Step 3. Most electrons, about 95%, reach the collector region. The collector base junction is reverse biased, which attracts these electrons toward the collector. These electrons form the collector current, IC. Step 4. The total emitter current is divided into base current and collector current. Therefore, I equals IB plus IC. Applications of NPN transistor. NPN transistors are widely used in electronic circuits for switching applications such as controlling LEDs, relays, and motors. Signal amplification in audio amplifiers and communication systems. Digital logic circuits used in computers and microcontrollers. Oscillator and timer circuits, power control and automation systems. Simple application. Example: for example, an Arduino or ESP32 cannot directly drive a relay because it provides very little current. An NPN transistor is used as a switch to control the relay using a small current from the microcontroller. Conclusion: in this video, we learned about the construction and working of an NPN transistor. We saw that it consists of three terminals: emitter, base, and collector. When the emitter base junction is forward biased and the collector base junction is reverse biased, a small current at the base controls a much larger current flowing through the collector. Because of this property, NPN transistors are widely used as switches and amplifiers in modern electronic devices.